My name's on the slide. I have Simon Liles and Stuart Liles up here with me. They're going to be essentially visual aids tonight, but they're here to answer questions too. Our talk is on social engineering your progeny to be hackers. In other words, we're hacking our kids, which sounds kind of not very nice. I suppose we could call it social engineering instead, and that sounds a little more polite. And it's kind of a hook to get you in here. The truth is, we're not really hacking them so much as we are creating an environment for them to learn new things, build new skills, do cool stuff. So it's not really specifically about teaching them to hack or about hacking, but it's a lot about two things. One is finding the motivation for your kids to engage in activities that lead to goals you set for them. We set some goals that we would like our kids to know the language of the computers. And you'll see where we go with that. There are some ways that you can find motivation. There are more parenting philosophy books out there than you can probably count. We've kind of used something called Love and Logic, which is really awesome. Basically, it's on the foundation that your kids get choices. You give your kids choices. The children feel like they have some control over their lives. And the parents are all going, oh, I don't know. You don't give them unlimited choices. You give them choices you can live with. Would you like peas or carrots with dinner? They can pick. Either way, there's veggies on the table. The other thing that this is about is challenging assumptions of learning. There are a lot of assumptions about learning. Who can learn? What the minimum requirements of knowledge and skill are before you can start learning some subject. We're going to challenge all of those, and we have been. This is not about being a helicopter parent. No helicopters allowed. Really, it's also about providing the ability to fail safely, because you learn so much more from failing than you do from succeeding. And anybody who has banged their head over some piece of code that simply wouldn't run, only to find the missing semicolon, understands that you've learned a lot. You think, how many hours, and it was a stupid semicolon. But now you look for them every time. It's one of the first things you look for. This is not a scientific study. Our sample, our N is 2, so that's not very big. So, challenging assumptions. I want to challenge the assumptions about learning. Who can? There are a lot of these, and I've heard them for many, many years. I spent at least a decade in higher education teaching, and I heard from other faculty and from a variety of students, oh, those students can't learn this topic, or these students aren't smart. And then you start talking about at what age do you start introducing subjects like programming to kids. Oh, kids can't work on computers. Small children can't work on computers until they can read. Kids can't learn to program until they have higher math skills. And I said, really? Are you sure? So I asked questions. How old do kids need to be before you introduce them to computers? Think about it. And what skills do they really need? Should it be reading? Should they have fundamental reading before you start with the computer? How about math? Should they be able to add and subtract at least, maybe do a little calculus? My answer is, how about age 4? And what you see are the boys at age 4. It started like this. We got a phone call from a grandparent who said, I have this stupid laptop, and it's broken. Do I just throw it in the garbage? With a little bit of discussion, we learned that yes, it was broken, but we convinced the grandparent to send it to our house. And Dad, who has mad repair skills, fixed it up. And suddenly, we have a brand new computer. And it was really fun. And it was soon joined by an identical laptop procured from eBay, because twins. And the key point here was, you use what you have, and you fix what you can. The kids watched Dad repair the laptop. These are 4-year-olds. They are pre-reading, and they have basic numeracy. In other words, they can count, but no other math skills. Now, remembering that I have this background in higher education, I understand things like prerequisites, learning objectives, motivations. So what are the motivations here? The kids get their own computers. No sharing required. This is a big deal. Everybody in the house gets a computer. They think they are cool beans. The learning objectives. What do we expect from the kids at this point? We want them to get familiar with the computers. We want them to learn basic navigation and basic keyboarding. All of this so that we're encouraging them to explore this environment. And what did I do at this point? Not very much. You know, we had everybody sit on the sofa and a little bit of demonstration, and I turned them loose. What's the worst that they could do? We loaded games on like Reader Rabbit, you know, and they played. It was a game. It was fun. If they got stuck, they got a little extra help. So the truth is, kids are curious. And that is motivation. And playing to that curiosity is part of the hacking. So kids ask questions, all kinds of questions. As a parent, you can become overwhelmed with, I don't want to hear any more questions. But you have choices. You can tell the kids, stop asking me questions. You can just give them the answer. You can distract them. Oh, look, a pony. Or you can help the kids find the answer on their own. If you're really working on hacking your kids, choose that last answer. Guide them to the knowledge. They say, how does this work? And you say, that is a great question. And then you teach them how to research it, how to find the answer on their own. And then eventually what happens is they ask a question and you say, you know, you have the entire internet in your pocket. Go look it up. And they do. And then they share that information with you, and it's a cool discussion. This is also about, as the parent, it's really easy to want to like kind of swoop in and help them. But really, for this to be the learning process you want, you have to step back. Give the kids the space and the time to explore, because they're learning by exploring. And how do you keep them progressing towards those goals that you set? Remember that we're giving them choices we can live with. So you can play Reader Rabbit, or you can read a book. Either way, I win, right? Sometimes the motivation looks like a bribe. And I'm okay calling it a bribe. So the boys are about 4th graders at this point, and they come to us very serious. And they say, so there's this Lego set, and it's kind of big, and it's kind of expensive, but we really want it. And the question is, well, how much? do you want it? What would you be willing to do for that Lego set? What you see here is Fundamentals of Network Security by Eric Maywald. This is a college textbook used in an Introduction to Information Security class. It meets the NATISI 4011 standards. And at 4th grade, those guys read it. They read every page. They did all of the self-check questions in the middles. They answered all the questions at the end of the chapters. Their motivation, they wanted that Lego set. So the deal was, read the book, you get the Lego set. Okay? The assumptions, let's be honest. This is a college-level textbook, right? They're 4th grade, they can read. Okay? The learning objectives for this were to get them some basic network understanding, some network security understanding, and some information security concepts. We weren't looking to turn them into information security professionals. We just wanted them to have the concepts. They're 4th graders, they're playing on the computer a lot. A little situational awareness might be a good thing. What did we do? There was a lot more discussion at this point. They would be reading, we would know what chapter they were on, we would ask them leading questions. So what can you tell me about password security? Good stuff. Yes. So, I'm bored. Everybody hears this, right? Every parent. I'm bored. I'm bored is actually an opportunity. In our house, it went something like this. We heard, I'm bored. We were on our way out the door for some errand. We said, you know what? Get on your computers, go find Alice on the internet, download it, and learn how to use it. We'll be back in a couple of hours. They didn't know what Alice was, but they found it, they downloaded it, they worked the tutorials, and we were off and running. It's really all about finding the motivation and providing choices you can live with. We're directing here. So, just so that you know, Alice is a free learning language created by Carnegie Mellon. It's very game-like. It is very much drag and drop. So if you want a loop, you basically drag and drop a loop. So there's no learning a programming language that's hard, but you're learning programming concepts. In this case, our motivation was, this is a new game. It was something to play. The assumptions were, kids can't learn to program. And in order to learn to program, you have to have higher level math and heavy-duty logic. Again, we're looking at 9-year-olds here. So the learning objectives in this case were learn basic programming structures. Loops, branching, sequence, methods, objects, because Alice teaches objects and object-oriented. What did I do? In this case, it was pretty loose because we were treating this like a computer game. After the initial download and the tutorials, they went off and they played. They asked questions. I provided about that much instruction. They needed to know, they were like, how do methods work? So I gave them about a 5-minute lesson on methods. They provided the example of what they wanted to do with a method. We worked that through, and they were off. The next, I think, 6 months to a year, they played with Alice extensively, and they had a blast. It was very, very cool. Now, this is the hard part. So they're playing with Alice. They're learning programming concepts. I'm doing little informal quizzes to see if they're really learning programming concepts. They are. You have to be ready for the next step. As the parent, you need to be thinking a step ahead. So they're learning Alice. So, you know, you better be ready when they want to learn something different, more. So it went like this. How can we make real programs like that we could share with our friends or sell? And what I said was, well, you have to learn a real programming language because you can't really do that with Alice. They're 10 years old at this point. And the question was, all right, so what programming language and how do we go about this? Now, I've done a lot of teaching of programming at all levels, introduction all the way through advanced and data structures, and I've worked with all kinds of students and multiple languages. And so we had some restrictions. We're working on Macs, so we have to have a language that's going to run on their Mac. That kind of put Visual Studio for C++ out of the running. I picked Java because I wanted an object-oriented language. I wanted a reasonably difficult syntax. And it was a good entrance into applying those concepts into the formal syntax of a programming language. The motivations here were the kids were really looking for, I want to do real programming. The assumptions, we're still battling this whole kids can't. So there is that. They're 10, so they still have not had calculus. Okay, can you learn to program in a language like Java without calculus? My answer to that is, oh, yes, you can. There's also this assumption that real languages like Java and C++ are too hard to learn. And I'm hearing that from college-level faculty. Oh, yeah, we're not going to teach those. They're too hard. Really? Maybe they're not that hard. So I made some contacts with textbook publishers, and these are the actual books. It is Java Software Solutions, and that is the 6th edition, which is no longer in print. We got 2 copies. At this point, I'm a little more involved. It's not quite as loose. In addition to getting the materials, we get the textbooks, we make sure that they have an environment to program in. I think we used NetBeans. And I read through all the programming exercises, and I pick the programming exercises for them to work. So they read the chapters, they come to me with any questions. I let them do the guiding. So if they don't have a question on a topic, and they can answer questions I have for them, they're golden. I don't bug them. If they have questions, I answer them, provide examples if I can, and I make sure the programming examples aren't asking them to do math they haven't been exposed to yet, because I don't want to teach them math and programming at the same time, because that's a level of crazy I'm not willing to go into. And I picked this, and then I did a lot of helping them debug, because that's also part of learning to program. You have to learn to debug, and it's frustrating. And they finished the Java book, and they wanted to do game programming. That's actually one of their goals. They want to write a game. Game engines are written in C++. So the next book was C++, How to Program. The other thing you get with C++ is you get pointers. Everyone can cringe now. But they're important concepts, even if you use a language that doesn't have them, because they help you with memory management. And that's also a really good thing to know how to do. So they're still working through the C++ book. They're about halfway through, which would put them about midway through a second semester of a C++ class in college. This is cool. Are we hackers? So where are we now? Well, here's the thing. Our goal really was not to turn them into hackers. Our goal was to give them a set of skills that they could carry with them everywhere they went, prepare them for this future that involves computers everywhere, and maybe keep them from having to flip burgers at McDonald's. You know, if your first job is writing code for a major company, rather than flipping burgers, that's not a bad thing. Right now, they're 14 years old. They have been programming for about 4 years. They have Alice, Java, C++, Robot C, which they learned in school. And the fun thing about that is they knew more programming than their teacher, and they taught their teacher at school some programming techniques he didn't know you could do. That was very cool. They went to Circle CityCon this summer and attended Georgia Weidman's pen tester boot camp, held their own, helped other students in the class, had a blast. And so far we've talked all about this very technically focused thing. You can apply these same techniques and concepts to all kinds of things, including physical health. So we have runners. We run every day as a family. We go on adventures. If we say to the kids, you want to go on an adventure? The answer is almost always
Yes. Yes.
not what's the adventure or where are we going, but yes. You want to go on an adventure?
Yes.
Because it usually means we're going to go do something really fun and cool. As parents, what we want is the best for our kids. We want to provide them all the tools for a bright future. That's the truth. The way that we've been getting there is providing tools and resources and the time and the space for them to go and do. We don't hover over them. We don't overprogram them. We haven't signed them up for 16 after-school activities and 34 sports, but we let them direct the kinds of things they're interested in doing. So sometimes they're working on their programming, and sometimes they're working on building with Legos, or making up fun stories that involve Transformers. And that's all good, because that's really what our goal has been. And I want to give you references for anybody who was trying to follow along. Loveandlogic.com is actually still up and running. It looks like it was built in the 90s. I apologize, I didn't write it. But it's still the good concepts. Alice.org, they are still going strong, and it's still a great little program for teaching concepts. And those are the actual editions of the books we used. There are newer editions of everything. So, I managed to finish in just less than 20 minutes. Do you guys have questions for me? Yes?
Well, I feel like I'm coming to the age of when I can be kind of parent, and nobody says anything about trial and error. Like, there's going to be a book that like will tell you how to do it. Do you have any hesitation? My thinking is, I only get one shot. If I mess this kid up.
Oh, well, so... That's kind of the answer. So the answer is yes, I referenced books. They have an older brother and sister. With the first one, I read all the parenting books, and within about 36 hours of being home with the first one, I threw them all in the garbage because they just didn't fit my kid. It was like, okay, these books aren't helping. So much of it is trial and error and talking to other parents whose kids are completely different than yours, and so a lot of it is you just go with your gut, and you know your kids. You know, I was talking about motivation. A lot of it is different kids are motivated by different things. Some kids need a little more pain. You know, if you introduce a little pain in their life, they go a little better. And by pain, I don't mean you beat them, but I mean you don't make life specifically easy. You know, you allow them to fail a little harder than is even comfortable for you. You say, gosh, you know what? I love you, and I will always love you, even if it takes you more than 1 year to finish 7th grade. So, yeah, but read the parenting books, and take what you can, and throw out anything that clearly isn't working. Yes.
I'm just kids. I have a 1-year-old, a 4-year-old, and one on the way in March.
Yeah.
And I'm really kind of blown away by all you have accomplished as a family. How do you find energy to go and find all these creative things to do and still get your kids to get dressed this morning and be there?
You know, so one of the things that I did early on was I made my kids pretty self-reliant. So I said, listen, what you wear is your choice. So we're leaving for school in 30 minutes, dressed or not, and our time is up. But I'm done, so. But it is again about those choices.